Okay, so today we are going to see the fourth lab program, that is sort integer elements by using QuickSort method. So we'll see what is QuickSort. So before that, we'll see what is the definition. So use this QuickSort method to take a input of 5000 numbers and draw the time complexity uh, chart. Then how to take an input for these 5000 elements. So you can take either read a element from file, or you can generate by using the random number generator class. Then compare the time complexity of average, worst case, and best case. So now we will see what is QuickSort. So QuickSort algorithm is a method of divide and conquer method. So what is divide and conquer? So divide and conquer is where your problem is divided into two parts and it is solved. All the divide and conquer methods uses recursive function calls. Okay, so what is the quicksort method uses? So it uses three pointers that are nothing but variables, where it uses the first one is pivot. So pivot is nothing but the element. It returns the position or index of the element where all the left hand side of its pivot are less than the pivot element and all the right hand side are greater than the pivot element. Okay, then there is a left pointer which points to the left hand side of the pivot, and right means right hand side of the pivot. So we'll see what that elements. So suppose I am taking an example of an array which is unsorted. So this is the index values. Now how after solving this example, after the first iteration, what will happen? After the first iteration, I will get, for this is just an example. So if you see, there's element that is number 4, which is at position 3 now, and these are the elements which are present here. Okay, so they cannot, they are maybe sorted or unsorted. So if you see the right hand side, again these are unsorted, but all are greater than 4. Now this is nothing but the again one list which is unsorted, and here it is again one list, this is unsorted, that is left hand side and right hand side. So what we will do in the next iteration, so in the next iteration we will call a recursive function and we will pass this array. Okay, then in the next iteration we will pass this array. Means your array is again, or your list is again divided into sublist until and unless it gets sorted out. So after the end of some 2 or third iteration, or maybe the nth iteration, we will get a sorted list. So that is how the quicksort algorithm works. So we will see in detail how it is done with the program. So this program is written in Java. So for that, we have created the class called as QuickSort. QuickSort has a, its data members are an array and the number n. So array is only declared, it is not initialized, because we don't know how many numbers user will give the input. So for that I have written the input function which takes input from the user. To take the input we have a scanner class. So scanner is the one which will help us to take input from the user. So just create a reference variable for your scanner object. Then there is a random number generator. So you use a random class to generate a random numbers. Now, how many inputs we want? So just enter the total number. So it is stored in n. Now I need to initialize this array with here new int of n. So array is initialized. So if I give n as 10, so your array is initialized with 10 numbers. Or maybe in the next subsequent iteration I can give, or simulation I can give 20. So array values is changed. So for that I have to uh, give the input to the array. For that I'm using a random numbers reference and I'm generating integer. That is next int is the method which will generate. Now we have passed something called as 1000 here. So 1000 is nothing but it is a range which generates a random numbers within that range. So now I have given 1000, so it will generate 0 to 999. And the numbers will be generated might be with a repetition. If I want to generate numbers between 0 to 99, so I can give only 100. So your range will be 0 to 99. Okay, so in our program I am using 1000. So our numbers will be generated are 0 to 999. Then there is a display function. So to display the sorted array, for that I have used extended for loop where the increment of I is not needed, and even we need not check whether the I is less than or n or length of an array. For that we have only passing the array reference variable. So if you pass this a, what will happen is the I value is incremented and it will check whether I is less than the length of the array. So while displaying I am using I. So suppose there are three elements, so this will check three times. I am not incrementing I. That is the extended for loop available in Java. Okay, or you can use this same condition and you can display the elements. Okay, so QuickSort has two methods, that is partition, and we need to partition and we need to sort it. Okay, so partition is a method which will help us to partition your array into two parts. Okay, then I will sort that left hand side partition and I will sort right hand side partition. So that is been explained here. That is, if you observe, this is the partition we have used. So this is the partition we have used. Okay, so this is the left side of the partition and this is the right side. So I am sorting, this is the p value, that is the pivot element. So I need to sort this here. So that's why that is p minus 1. So I need to sort left to p minus 1, and from p plus 1 means here this one to till the right side. So that is the program that is being sorted. So that is given. So quick sort left and right. I will pass the left hand side and right hand side of the index, that is the starting of the array and end, and I will try to sort out. So we'll see what is the partition uh, method and how it uses and what is the initialized conditions, all those things. Okay, so the partition method, what it will do is when we pass the arrays, the left index here and the right index. Okay, so it will partition your array into two parts. So to partition that, we need a pivot element so that we can take the pivot index and all the left hand side elements are less than this and all the right hand side are greater than this pivot element. So to do that, what we will do is we will have the initialization. So what is the first initialization of our program? So for that, if you see, pivot element is initialized with a of left hand side initially. So left hand side is nothing but the 0th index. Then right hand side is nothing but it is the number of elements. Suppose if I passed 10, then it will have 10 plus 1. Okay, so we'll see what will happen here. We are checking each of the time, that is I, that is initialized with 0 because left is 0. Then j is, if you take suppose example as 10 means it is initialized as 11. So I'm constantly checking the left hand side is less than the right hand side uh, index, because constantly I'm increasing the I value and decreasing the j value. So what is the I value? So I is nothing but uh, here at the left hand side, so at the 0th, and j is nothing but it is pointing out of my array, that is index here at the 10th index. So we'll see why it is pointing outside. Okay, so what is the pivot is initialized? Pivot is initialized initially at the starting of the array, this one. Now what I will do is I will constantly move my I and I will decrease the j here. So whom I will check? So I will check with the pivot element. Means I want to find the element, means I want to position this phi or any of this element in the array, where if I position here pivot means the left hand side are all are less than this and right hand side are greater than that pivot element. Now I have chosen pivot element as element 5. So 5 is chosen this. So what is the position of this element 5? What is the index? That's what I have to look into. Okay, so I have initialized this. So what I will do, constantly I will move this in the right hand side and left hand side. So I is checked as whether uh, the next element is less than this, and j is checked to check whether that element is greater than that. So to find the greatest element and the smallest element in the two iterations, I am moving in left side and I am moving at the right hand side. Okay, so we'll see how the program goes with the iterations. Okay, so with the initial setup, the I value is 0 and the j value is at index 10. Now I am checking is 0 is less than or equals to 10. Now I am checking go with I plus plus. Okay, so I is incremented to 1 because I is 0. Now I am checking whether the next index is less than pivot element. If it is so, I will continue incrementing it. Otherwise, I will stop. Same with j. So j is decremented. So initially it was at 10. Now it is decremented to 9. And I will check a of jth position whether it is greater than pivot. If it is greater means I will constantly decrease the value of j. What we will do is we will continuously do these things, and after that we will swap I and j because they are actually uh, the value lesser than the pivot element and greater than that. So I will swap those elements from here. So we will see. So initial lookout, that is I is less than, that is 0. So I is initially here. So I will increment I initially. So it will move here, increment I. Then I am checking whether 6 is less than 5. No. So I will stop here. Then is 9 greater than the pivot element, that is 5? Yes. Then again I will move to the this side, j minus minus, because it is do while loop. It is continuing. So 8 is greater than 5? Yes. So I'll move here. Then 35 is greater than 5? Yes. I will move. Is 25 is greater than? Yes, I will move. Then again I will come here and I will check. Yes. Is 3 is greater than 5? No, I will stop. So now j is pointing to the position 5 and I is pointing to the position 1. Okay, so I will just make I is pointing to the position 1 and j is pointing to the position 5. Okay, so according to our program, we need to interchange these two. So if you see, if I and j are not crossed themselves, then we need to interchange, we need to swap. Okay, so what will happen if these two get crossed? What will happen? So if these two get crossed means we need to swap with left with the jth element and we need to return the position of j. That is the index of your pivot. So we'll see those two conditions in the next iteration of our problem. So now what we have to do is we need to swap I and j. So what is swap? So swap is nothing but it will take the index values of I and j and it will swap with the arrays. Array, what are the values stored in that index? So a of I and a of j. So I am giving I and j as the index and it will swap the, the elements present in that index. Okay. So now the I value is 1 and j value is 5. So we need to swap this. So after swapping, I will get j comes here, that is 3. Then I will get here 6. Okay. But your I value is present here. So now if you see 3 is present came here and 6 goes here. So j is pointing to again position 5 and this. Now the index I is now is 1 and j is 5. So again we are continuing with our while loop, that is I is less than or equals to j. So this time it comes 1 and j value is 5. So less than or equals to 5. Yes. Yes means again we need to move the element. So we need to move the element, that is this time the I value has 1 and j value is 5. So I plus plus, so I is now moved to 2. So I am checking a of I is less than that. And again, the same iteration goes on. So if you look into that program, if you look into this program, so what is happening? So I moved the I index here. Yes, a of I means 1 is less than 5. Yes, it is less than 5. So I will move again here. Is 2 is less than 5? Yes, it is less than 5. Then again I will move here. Is 10 is less than 5? No. So I will stop. So I will stop there. Then I will go to the j and I will again decrement j and I will come here. Is 10 is greater than 5? Yes. Yes means again we need to move here. So what has happened? So j is now 2. Is 2 is greater than 5? No. So we need to stop there. And if I and j are crossed, I and j are crossed means yes, we have done the things because we have found the position of the element, that is pivot. It should be present here. So what we need to do is we need to swap with j. We need to swap with j. Means 2 goes here and 5 comes here. Now if you observe, we will return the jth index. That is index is nothing but 3. That is the position of your pivot. Now pivot is pointing here. So now the pivot is pointing here. So what we need to do? So if you observe, the elements which are at left hand side of the pivot are unsorted, but they are less than the pivot element, and right hand side are all are greater than the pivot element, that is 5, but they are also still unsorted. So what we need to do? So we need to call again recursively only at this list. So how to call? Now my left hand side is starting with index is 0, but right hand side is only p minus 1 because index is 3 sorted out. So I need to sort till 2. So p minus 1. Okay. So pivots index minus 1. Next, we need to sort this right hand side. So I need to start with left at p plus 1 because this is the left starting position, that is 4. Then right hand side is remained this 9. That is what right. So if you do this, again this list is sorted and again this list is again divided or applied divide and conquer and recursively it is sorted out and you will get the sorted elements. So we'll see the program. So that is how the this program goes on. So again, the methods are called. What is the main method of this program? So the main method is create a class or reference variable QuickSort and call the input method. So I'm just displaying what are the arrays before sorting, and I have taken the time to sort. So to sort, this is the method. QuickSort is the method which will sort the list. So my system time starts at before calling this method, and after calling this method, it will end. And I want to print it in milliseconds. Okay, so end time minus the start time will give me the duration divided by this. So I will get the milliseconds. Then array after sorting, I will display again array after the sorting and what is the duration to sort this element. Okay, so if you observe, I have called quick sort method with initially zeroth index with n minus 1 elements because I am starting with 0 and continuing till n minus 1. So if you observe my example, if you see the example, the index value start at 0 but ends at 9. So because there are 10 elements, so that is how it goes. So when you call a quicksort method, if you observe, so it will partition the array into left and right. Then it is calling recursively the quicksort method again and again. So the method quicksort, the method which calls itself is called a recursive function. So it will call again and again this method. So again, the left index, that is I and j, are initialized with whatever we have passed. So suppose if you remember that quicksort, the left hand index is 0 and now the p minus 1 is the position was 3, so it is given 2. So next iteration, the quicksort was p plus 1 means 4 comma, that is right means it is 9. So we need to sort this. So quicksort. So again, so we have partitioned only till this index and this index. So it will goes on like this and you will get at the end the sorted array. So we'll see the output of this program, how it runs. As you can see, I have given the numbers as 10. So this is the unsorted list initially, and after sorting we are getting sorted list, and if I am getting this is the uh, uh, time required or duration required to sort those elements. So I will change the numbers again. So I have given the numbers as 50 because I am giving it in the row wise. So if I give as column means next column means it will take a huge uh, display area. So I'm just going like this. So there are 50 numbers and they have been sorted out. Okay, so it is taking 0.20 milliseconds. The numbers can be repeated here, no problem, but they are all random numbers generated by using that random class. So I'll goes on increasing the numbers. So now I have given 150 numbers. So it is been taken and it been sorted out. So it is taking some 0.453 milliseconds. So as you can observe, there can be a worst case or average case because I am not giving a number by own. It is taken a random numbers. So based on that, your time complexity is increasing. Okay. So time complexity of that quicksort gets increased with that given the n elements. So if there are the elements are less, it can be sorted in the fastest way. Okay, that is end of this program. Thank you.